once I will ask Shubham the centrifugal pump, draw centrifugal pump, and explain like that. Then same question I will ask to you also. Is it fine?
Okay.
And where you did the
Yes.
degree?
Okay,
and
then
what is
let's
your degree percentage?
Shubham,
and about your family members.
from
Means
first
like
I will start from non-technical.
Mother's profession,
Okay.
if you have siblings,
Okay.
their profession.
Okay,
And
introduce
then,
yourself, Shubham.
I think
Good evening, sir. First of all, thank you for giving me this golden
things only
opportunity
he
to
will ask
introduce
me.
myself in
So
front of
only
you.
tell this
My
question.
name is Shubham
When in my
Chaturvedi. I am
interview-
from
interview
Jaipur,
he will,
Rajasthan. Coming to my
I give some other
academic,
interview.
I
He
am
also
pursuing
told
my
that
BTech
only
from
these many
Sri
things only
Balaji
you
College
tell
of
me.
Engineering and
Don't tell
Technology
in detail
with an
everything, because
aggregate
they also will
percentage
want to
87
so many
percentage.
interviews will
I
be
have
there.
completed my diploma
So
from
only,
Jaipur Institute of
again you
Polytechnic College
introduce.
with
Don't
an
tell
aggregate
hobbies and all.
percentage
Just
70
tell
percentage,
things.
and I have completed my
Okay.
secondary
My
education
name is
from
Ahmed
Saraswati
Shishtava. I am
Vidyanidiketan
from
School, Jaipur
Kerala,
with an
Kasaragod
aggregate
district.
percentage 78
I have
percentage.
completed
My
my
hobbies
schooling
are
in CBSE Board of
writing shairi
Education
and
in
ghazals,
Mangalore.
cooking,
I have
riding,
completed
trekking,
my
gymnasm,
PUC
etc.
education
And my
in
achievements are
Karnataka
awarded
Board
as a
of
best leader
Education,
award
and
by
I
the
have
Jaipur
completed
Super
my BE
Bikers
in
to
Mechanical
continuously
Engineering
organizing a riding
from
program
Vishwesvaraya
and won a
Technological
gold medal in
University
karate
in Mangalore.
championship. That's
I
all
have
about
scored
me.
Okay, why do you want to join merchant
I've
navy?
scored 82 percentage
Merchant Navy.
aggregate in my
So
BE in
merchant Navy is a
Mechanical
passion
Engineering.
towards machine. This
And
passion came to me
talking
from my
about my
grandfather
family,
and my father
I
because they
live with
both are
my father,
mechanical
my mom,
engineers,
and a sister.
and this is the reason
Then
to take
now
a
tell
mechanical
professions, means
engineering.
what they will
And
do.
when I am in the second year of my
Means
diploma, one of my
they will
relatives
ask
who is
the
in the
profession
merchant
of
navy
the
had
means
told me
fathers
about the
and
merchant
parents
navy
and
life,
siblings
its
they
opportunity
want
and
to.
challenges.
Tell me.
That day,
My
that day I
my
have
father is
decided to
a
enter in this field.
businessman. My mother is a
So
teacher,
merchant navy
and my
helps me to
sister
use
is
my
a
technical
she's
knowledge into
studying in
practical
8th
hands.
standard.
So merchant navy is not a job for me;
Then
it's my life.
why
So
you want
that's
to
why I
join
have
merchant
transformed
navy?
myself from 110 kg to
Sir,
75 kg. Sir, I want to
talking
live this
about why
life.
I want to
This is
join
my
Merchant
solid and
Navy.
rock reason to
Merchant
join
Navy,
merchant
I
navy.
think Merchant Navy is
Okay,
not
why do
just
you
a
want to
job.
join
It is a
Anglo-Eastern?
lifestyle which I
Sir,
am craving
Anglo-Eastern
to
is
live throughout my life since
Anglo-Eastern is
my
one of the
first
biggest
PUC
shipping
education.
company around the world, and
Working in a engine room with
it has a
huge
best
room with
best
huge
training
machines has
facilities,
always been
and
my dreams,
Anglo-Eastern
and
is
for
also
that dreams
awarded
to come true,
as a
I've
best
always been
pre-sea training
working
institute in
throughout my life.
2000 best
And
pre-sea
my
training
qualities
institute
and
award in
my qualities and
2019 and
my responsibilities
2023,
I know
and
well to
it has a
take
less
my
waiting period, so
responsibilities.
that's why
So
I want to join Anglo-Eastern.
I thought of
Okay.
joining Merchant Navy once or
I
twice,
will ask the same question to you,
once
Manuel.
or twice the things
Okay,
that I have
introduce yourself.
decided. I never give up on whatever the
Okay, so
condition it is until
my
it's
name
all
is
over. One
Faradays.
such
I hail from
example I would
Kerala,
like to
a
share
traditional
is
state in the
in
country,
a
India.
kabaddi match.
I
I
live with
was the
my
captain
family
of
in
our
former
kabaddi
boss.
team, and our
My
team
father is a practicing lawyer,
wanted
and my
around
sister, she
5
is a
to
dental
6
doctor in
points, and
Qatar,
there was only
and my
2
mother, she
minutes
is a
left.
homemaker,
And I
and
could
that one of
easily
our family
score
too.
that 6
I
points
had
with
completed my
good
BTech
plan
Mechanical
and
in the
techniques
year
used.
2021,
Even our coach
and
was
after that, I had got a
surprised
chance
by
for
the way we
placement
played.
in Chennai Wapco,
Other
where
than
I
this,
worked for 3 months.
I have a good captaincy
And due to the
captainship
non-technician and due
quality
to the non-technical exposure given
I
there, I
always
had
lead my team
shifted from
throughout.
there
And
after 3 months
during my schools,
and
I
joined
was
in
the
the
captain of
Faradays,
our sports team
where I
and
got a
also
great
other
technical
cultural
knowledge
teams.
of
And I
during
always respect my
those 1
seniors,
year.
and I always
After completing
great
the apprenticeship there in the
leadership.
Faradays,
I respect
I'm
my
in front of you
seniors
to give
and
the interview
always
to
obey the rules
Anglo-Eastern.
and regulations and
And
work
I had
according to
in BTech, I had
according
a
to what my
percentage of
seniors
71,
will
and in the 12th
direct me
degree,
to work.
I have a percentage of
Apart from
81,
this, I am
and
self-confident.
in the 10th, I
I
have a percentage of
I am
90.
self-confident. Yes.
Okay.
That's about myself.
Okay. Did you told about your profession of your parents and siblings, if there is any?
Means like 6 points.
Yeah, I had told.
Means you
Yeah.
have
Like my father is a practicing lawyer, and and my
you
sister is
never
a
give up
dental
attitude.
doctor.
So
Okay.
you can add up.
Okay, why do you want to
after
join
that,
Merchant
I think
Navy?
this attitude will help
Actually,
in
my
this onboard ship also.
my two
So
cousins
that
have inspired me a lot
so
for
that
joining Merchant Navy.
this never
Due to
give up
due to the
attitude
work that is
will
related to
helpful
mechanical engineer
in the onboard ship
and the
where I can
environment
make
in the and the core
where
mechanical
with
engineer attracted me to the Merchant Navy.
let's start the
A
technical
great job with
discussion.
punctuality and the passion
Draw the
for it
centrifugal
have
pump and
strived me
explain
to
how
join
the
the Merchant
discharge
Navy.
pressure is created.
Okay, why do you want to join Anglo-Eastern?
As Anglo-Eastern is one of the and most reputed and quality-wise most like mostly very talented people's company
Yeah, it is
in the
proper.
world. and I think person have very good, very good practice stuff between them, so that I can interact with them and make my career opportunity great and widen my opportunity.
Okay, now both of you, I will ask this question, means draw the centrifugal pump and explain how the discharge pressure is created at the discharge side of the centrifugal pump.
Okay. The centrifugal pump works on the principle of rotodynamic principle. If the mechanical energy is converted into pressure energy by means of centrifugal force, the hydraulic machine is known as the centrifugal pump. It consists of many parts like the impeller, casing, foot valve, spinner, inlet valve, delivery inlet pipe, and delivery pipe and delivery valve. When we switch on the pump, there is already some amount of water is present inside the pump. As the impeller rotates due to the high kinetic energy of the water, pressure is reduced, so a negative pressure is created at the eye of the impeller. So the water is because there is also a slightly low pressure is acting on the pump, and due to the relative pressure difference, the water is sucking from the dryer. In dryer there is enters into the eye of the impeller, passes through different systems like the footwall and absorbing the moisture and enters into the eye of the impeller. Due to the centrifugal force imparted on the water coming out of the guided wheel vapor is then saturated vapor. Due to the design of volute casing, volume is increasing and the velocity is decreasing. So the kinetic energy of the water is converted into the pressure energy. That's how the discharge pressure is created
where
inside
sudden
the pump.
drop in the pressure takes place. As the pressure drops, the temperature also drops.
What happens if air enters
now
inside the centrifugal
the
pump?
refrigerant is in the form of liquid vapor mixture.
If air is present,
The saturated liquid vapor mixture.
centrifugal pump, the developed head will be top because the density of water is 1000 times the density of air. Water is incompressible in nature and air is compressible in nature. So air is not capable enough to create enough suction pressure inside the pump.
From
So water will not
liquid vapor mixture into the
also water will not push out through the pump. So the pump will run dry and
then
it gets
there is a
overheating. So the pump performance and the efficiency of the pump is also
if the temperature
decreases. These all are the
above
consequences when the air is present
minimum
at the suction
above the maximum temperature, or if it is below the minimum temperature, it sends the information through the capillary tube to the thermal expansion valve. In thermal expansion valve, when it gets the signal, it regulates the size of the orifice according to the signal it gets received. If the temperature is high, if the temperature is high, the orifice will be opened more. If the temperature is low, the orifice will be closed. And the windings will be destroyed.
There is also reason that the efficiency of the pump will also be reduced by such.
Therefore,
these all are the problems which occur when the air gets inside the pump.
And you didn't mention about the suction pressure will be reduced, no, because air enters because the density of the air is 1000 times lesser than the water. So
I had also explained that suction will not be initiated.
Why you mentioned that this means density of the water is the density of the air is very less. You mentioned that.
Factors. One such factor is the type of refrigerant we use in the refrigeration process.
Both of you draw the gear pump and explain how the discharge pressure is created. It depends on the type of refrigerant we use. Okay, then what are boiler mountings? List out the boiler mountings.
Some of the boiler mountings are pressure relief valve, safety valve, water level indicator, blow off cock, steam stop valve, feed check valve, fusible plug, low level water indicator, cum valve and air vent cock is reduced below the minimum level.
As the gear comes out of the mesh, the volume gets increased, and so the pressure is decreased. So the fluid enters into the mesh, and it gets inside the teeth of the gear. and at the,
some of the
discharge
compressor
line,
safety devices are released from bursting disk fusible valve,
and due to that,
air high
this is due to the
temperature
reason
trip,
that
water
the
high
gears get
temperature
into the
trip,
mesh,
water no flow trip,
and here
In
the pressure
compressor
is
there is no relief
being increased
more
due to the reduction of volume.
no relief valve.
So here
Bursting
the
disk you
discharge
have
pressure is created
compressor.
by this phenomenon.
How volume is decreased? When gear will come into mesh, then volume is decreases.
Yeah.
No, in a discharge side.
Yeah.
You
I have
didn't.
mentioned that. Yeah, I have mentioned that. Like when, I had told you like that when the gear get into the mesh,
Yeah,
the volume gets
Yes, I
decreased
had done some notes
and the pressure will
before.
be increased.
Before I had
You
done
told,
some
yeah.
notes.
Okay. Be
So in
careful
that I
inside
got
it.
from
When
Google.
measuring in starting you told that gear is out of the mesh, then volume increases, pressure decreases. In discharge side also, when the gear come into mesh, volume decreases, pressure increases.
Alarm and trip, bursting disk,
Okay, if you mentioned, then it is fine. Proper answer.
no flow trip or water.
Okay, this is my diagram right now.
Only this many.
Yeah.
Yeah.
अब ठीक है देखो.
Yeah.
Moisture drain valve and air
The
high
gear pump is a
temperature
type
trip,
of
that is
positive
not needed.
displacement pump. It uses a mechanical meshing of the gears to transfer
Moisture
fluid
drain valve, that is
from
there.
one
One
point to
I
another
found
point.
it from
It
Google
consists
before
of
your
two
notes.
spur
I
gears.
got.
One is the driver gear and second is the follower gear. These both gears are revolving in opposite direction. Only a few inches of clearance is exists between the casing and the gear. How the pressure is created. When the gears are out of the mesh, then the volume is increases and the pressure is decreasing. So there is also atmospheric pressure is acting on the pump. So due to the relative pressure difference, the suction is created inside the pump. So water is sucked from water enters from the suction side of the pump and enter between the faces of gears. When the gears are into the mesh, pressure is increases and volume is decreases. So
Faraday's law states that whenever conductor is placed
liquid is
in
pushed out of the pump
varying
to the discharge
magnetic
pipe.
field,
That's how the discharge pressure is created inside the pump.
electromotive force is induced. Electromotive force is created. And if the conductor is a closed circuit, then the induced current is
Next
called
question
as
which we will ask is VCRS.
then the current
And
is
can you draw
called
the
as induced
VCRS
current.
and explain it?
Yeah.
So
Faraday's
for some
second
people
law of
he asked
motion
to
states
draw
that
also.
when a coil produces an electromotive force, if engine is less as compared to the thermal efficiency of the four-stroke engine, the volumetric efficiency of the two-stroke engine is less as compared to the volumetric efficiency of the four-stroke engine. Two-stroke engine have a longer length of strokes than the four-stroke engine. Two-stroke engines are used on two-stroke engines. That's it.
Okay, this much is fine.
Yeah, it's proper.
And what you told that engine is bulky. I mean, thermostatic expansion valve is there. No, can you draw it like how sir used to do with the cross like this?
Two-stroke engines are
Okay,
cheaper
yeah,
in
I
price
have seen
because
that
the
they
engine is
the
bulky
relief,
and
relief wall. We
not
are
so
just drawing the
complex.
relief wall like that.
Like that.
We are drawing that.
Horizontal relief valve.
In four-stroke, the engine is heavy.
Okay, I will draw it.
Okay, can you explain the working of
Yeah,
the
I can
VCRS?
explain. Yeah. Okay. VCRS is known as the vapor compression refrigeration
Because
cycle.
the two-stroke
It consists
engine
of
is
four
bulky, the
stages:
cost is
evaporator
less.
with the
I
isobaric heat
don't,
addition,
I don't
and the compressor
so
with the isentropic compression, condenser with the
instead of
isobaric
this,
heat
other
rejection,
points are,
and thermostatic
very
expansion
fine,
valve
so
with
you
the
can tell that.
isenthalpic expansion.
Then
The
in,
cycle starts
this
from the
is this
compressor.
point correct?
When
Like
the low pressure and low
two-stroke engines are
temperature,
cross-head
vapor
type engines.
refrigerant is coming out of the
cross-head
evaporator
is
and
there.
enters into the
Because to
compressor.
connect
Then
the
this
upper
low pressure and low
piston-
temperature vapor refrigerant is coming in,
Four-stroke are
convert
trunk
into the
type
high
engine.
pressure and high
This you can
temperature superheated
Because the
vapor.
cross-head
Then this
is
high pressure
because
and high
the
temperature
connecting rod is
superheated
so
vapor
long, no, so you
refrigerant
cannot make it.
is
So
enters
cross-head is
into the
used to
condenser.
connect the
Condenser is a type of heat exchanger
upper
device which
crankcase and,
rejected the heat
this
from the
part.
refrigerant and convert the
In
refrigerant into
cross-head
high
engines,
pressure slightly
piston
low
rods are
temperature
used.
saturated liquid.
Yeah, means
Then
it
this
is
high
very
pressure
long,
slightly
no?
low
Means
temperature
four-stroke
saturated
connecting
liquid
rod is small compared to the
is
two-stroke.
enters into the dryer. In the
So
dryer there is a
so
silica
you
gel is
can
present which is
directly
used to
connect to
dissipate the
the
moisture
crankshaft
inside the
means
refrigerant.
crank.
After
But
that
in a two-stroke it is
refrigerant
a very
enters
big
into the
bulky
thermostatic
so you
expansion
want to
valve.
use the
Thermostatic expansion valve acts like an orifice in which
So
the
it is fine. The rest and all is fine. Only
refrigerant
that,
is converted
because
into
it
the
is
low
bulky,
pressure and
cost
low
is less,
temperature
it is- I don't
liquid
think
plus
it is logical,
vapor mixture refrigerant. Then this low pressure and low temperature liquid plus vapor mixture refrigerant is transferred to the evaporator. Evaporator is also a type of heat exchanger device which absorbs the heat from the surrounding and converts the refrigerant.
Centrifugal pump works on the rotodynamic principle. Reciprocating pump works on the positive displacement. Reciprocating pumps
and low temperature vapor refrigerant.
Reverse piston principle.
Then
the centrifugal pump,
which is used to
the centrifugal pump have a moving part as the impeller.
If the temperature of vapor
reciprocating pump have the piston as a moving part. In a centrifugal pump, priming is required. In a reciprocating pump, priming is not required. Centrifugal pump have high discharge and low pressure. Reciprocating pump
if the temperature of vapor refrigerant is
high pressure, low discharge. In centrifugal pump, the discharge is the flow is in constant rate. In
will constrict the flow of the
reciprocating pump, the discharge.
Okay, thermostatic expansion valve, which law it follows?
It follows the adiabatic law.
Centrifugal pumps can pump only the
मैं जब सर्च किया था ना वहाँ आइडियल गैस फॉलो करता है करके था
pump only
आइडियल गैस मतलब adiabatic भी आइडियल गैस में
high viscous fluid
no heat transfer
any kind of
no heat transfer होती है उसके अंदर
हाँ मतलब वो फास्ट होता है ना ओरिफाइस छोटा रहता है मतलब वो फास्ट प्रोसेस होता है इसलिए adiabatic लॉ करके
sea water pumping ballast pump etc.
एक्चुअली वो डायरेक्टली आइडियल गैस लॉ को फॉलो नहीं करते क्योंकि सैचुरेटेड लिक्विड है आइडियल गैस तो गैस होता है ना पर हम अज्यूम करते हैं कि वो आइडियल गैस फॉलो करता है करके हम अजम्पशन लेके हम सब सारा मतलब करते हैं वैसे वो theoretical pump plus sludge. Okay, Manuel, can you show? I don't know exactly the reciprocating pump will also does that because sludge is very highly viscous, no? So I am not sure about
applications. I won't say application. I won't say.
Yeah, better
instead of that.
Yeah, it is
efficiency of centrifugal pump is high. Then efficiency of reciprocating pump is less. Then maintenance of centrifugal pump, maintenance of
VCRS is VCRS performance for VCRS is one of the compression refrigeration system in which in this thermodynamic process of cooling process takes place. In it we use refrigerant as a working fluid. This VCRS contains of 4 stages: isentropic compression, isobaric condensation, isenthalpic expansion,
more he will do.
And
like for you, how we did
isobaric evaporation.
Unless you tell something wrong, no, he will not.
At first stage, the low pressure, low temperature vapor from the evaporator is inside the compressor. And here the compressor compresses it into high pressure, high temperature superheated refrigerant.
This opens canals
and after that it goes into the condenser. The condenser, as we know, it is at a heat exchanger in which the temperature of the water is lowered from superheated evaporated vapor into saturated vapor. After that,
saturated liquid.
No, sir. I'm saying about when the superheated when it changes into the reason for the temperature decrease is because of the superheated vapor comes into saturated vapor. No, in that graph.
No, it will reach to saturated liquid. After becoming superheated, it will come to saturated. It will become saturated vapor. Then it will become after condenser. Then it will get to saturated liquid. And another thing, don't tell the saturated vapor. It will get confusion with directly when it enters into the condenser. It becomes saturated liquid. In the gear pump,
when it enters into the condenser, it will convert the high pressure, high temperature superheated vapor refrigerant into high temperature, slightly less temperature liquid, saturated liquid. After that, it passes through the dryer, and in this space, the moisture of the dryer, moisture of the refrigerant is taken out. And after that, high pressure, high temperature liquid passes to the thermostatic expansion valve. Isenthalpic process is being taken off. As we know, thermostatic expansion valve acts as an orifice where sudden drop of pressure takes place. As the sudden drop of pressure takes place, temperature also reduces. And here it is converted into high pressure, high temperature liquid is converted into partially vapor and partially vapor and partially vapor and liquid. that is 80% of liquid and 20% of gas, where it's converted into
vapor,
compression low temperature.
20% of the vapor. Don't tell
vapor.
Vapor.
Vapor. And after that, it passes through the evaporator. It passes to the evaporator, where the heat absorption is taking place. In evaporator, the heat is taken inside the evaporator to maintain the cooling. And here the 80% liquid and 20% vapor get converted into vapor. This vapor, the ensuring of this vapor is done by sensing bulb. And if the temperature of the evaporator the sensing bulb gives a message to the. Am I audible?
Yeah, sensing bulb you tell again. If the temperature.
Okay. If the temperature is more, the sensing bulb senses it and gives a message to the thermostatic expansion valve to open the orifice. And if the temperature is reduced, that sensing bulb will give the message to the thermostatic valve, so it shrinks.
With the help of capillary tube.
Yes, with the help of capillary tube.
Yeah, you have to mention that. Okay. So this is the working. And Shubham, instead of your adiabatic law, you tell isenthalpic expansion only. That is in every book it is given as isenthalpic expansion only. So keep in mind and you tell that on the isenthalpic expansion. That is the best thing. Because when I was studying for the gate also, in that in the IES railways, in that also they mentioned that isenthalpic expansion. There was no mention of an adiabatic law. And I heard adiabatic law when we used to do the session in the with Gyan and other people. They told that it is adiabatic law, but better you mention isenthalpic expansion only. I also told isenthalpic expansion only in the interview also. So it is good. Okay. Then can you tell the difference between 2-stroke and 4-stroke?
Yeah,
tell Shubham.
Okay. The number of strokes the number of strokes in a 4-stroke, the number of strokes in a cycle in the 4-stroke engines are 4: suction, compression, expansion, and exhaust. The number of strokes in a cycle in the 2-stroke engines are 2: suction, compression, expansion, and power. Number of cycles in a 4-stroke engine is equal to the half of the speed of the engine. Number of cycles in the 2-stroke engine is equal to the speed of the engine. Power developed is more in the 2-stroke engine, and power developed is less in the 4-stroke engine. Power to weight ratio is less in the 4-stroke engine. Power to weight ratio is high in the 2-stroke engine. And valves are open and closed by the help of mechanical valves in the 4-stroke engine, and valves are open and closed by the helps of piston in the 2-stroke engine. Heavier flywheel is used in the 4-stroke engine due to the irregular torque is produced, and lighter flywheel is used in the 2-stroke engine because the regular torque is produced. The power is developed in alternate revolution of the crankshaft in the 4-stroke engine. Power developed in every revolution of the crankshaft in the 2-stroke engine. And the 4-stroke engine consume less fuel, and the 2-stroke engine consume high fuel. Lube oil cost is less in 4-stroke engine, and lube oil cost is high in the 2-stroke engine. Okay, that's all.
Lube oil cost is high in the 2-stroke engine?
Yeah.
Are you sure?
Yeah, I'm sure about that. I have written from the notes of someone. Yeah.
I think it's more in 4-stroke now. Like we use the more lube oil in 2-stroke.
Okay.
Yeah, correct.
So the lube oil cost is more. Lube oil cost is more in the 4-stroke engine, and lube oil cost is less in the 2-stroke engine.
वही तो मतलब 2-stroke में सारा सस्ता वाला ही दिया जाता है क्योंकि वो ज्यादा कंज्यूम करता है बोल के. That thing I remember, so I got down. Okay, Manuel, can you explain the difference between 2-stroke and 4-stroke?
Okay, all the 4 cycles, intake, compression, power, and exhaust take place in 2-stroke in 2-stroke engines, and all the cycles takes place in 4-stroke engines. Due to the high temperature, and pressure, the thermal stress on two-stroke engine is more than in four-stroke engine.
Yeah.
In four-stroke engine, thermal stress is very less, and the more power, the horsepower is twice more larger than four-stroke or two-stroke. And to talk about due to poor scavenging, volumetric efficiency is less in two-stroke engines. Due to good to proper scavenging, volumetric efficiency is more in four-stroke engines. More headroom is required for two-stroke engines. In four-stroke engines, we require only less headroom. Due to the consistent power, torque delivery, we need lighter flywheel in the two-stroke. But due to the improper inconsistent torque production, we need a larger flywheel in four-stroke. We can burn a cheap quality of fuel in two-stroke, but in four-stroke we cannot burn a low quality fuel. We must have a good quality fuel in four-stroke engines.
ये point ना Manuel, don't mention this point because I have asked one person in merchant navy only. He told that for a four-stroke and two-stroke same quality of the fuel only they are using. They are not using the different quality of fuel. So
I thought because of the stroke length, I thought
no,
it can burn.
I also thought the same, but when I asked why four-stroke is used as an auxiliary engine, no. So I told that because of the because of high quality of the fuel we are using in the four-stroke, so we might be using. But no, answer is because for both two-stroke and four-stroke same quality of fuel only we are using. So don't mention that point. And he is the person who interviewer. He already sailed the ships. He knows that in both ship also both engine also we are using same quality of fuel. So he might reject you. So better you don't mention.
I should know. Okay, I will mention.
Other points are so many is there, no? Like that.
Yeah.
Tell that.
Yeah. Okay. And it is used to into stroke engines. The power to weight ratio is more. But in four-stroke engine, power to weight ratio is less. And the lube oil cost is less in two-stroke engines, but in four-stroke engine, lube oil cost is high.
Yeah. This much is fine. And then in our time after this question, if you want to ask, no, he will ask boiler mounting. So we will do that. Okay, boiler mounting.
Okay, there are different types of boiler mountings like the water level indicator, pressure gauge, safety valve, steam stop valve, blow-off cock, fusible plug, blow-off, and feed check valve, air vent of cock, and the scum down valve or blow down valve. These all are the boiler mounting.
Explain, or he can ask anything. So.
Okay, the boiler mounting, the water level indicators are used to check the water level inside the boiler. It is two in number and it is situated at the front of the boiler. The pressure gauge, pressure level indicator. It is used to indicate the pressure level inside the boiler. And it is also fitted on the front of the boiler. And steam stop valve, its main function is to stop the steam whenever the temperature is higher than the desired value. And the air vent of cock is used.
Temperature, not pressure. स्टीम स्टॉप प्रेशर कुकर में तुम सीटी जब टेम्परेचर ज्यादा होने से होता है या प्रेशर ज्यादा होने से होता है? प्रेशर ज्यादा होने से ना, तो फिर प्रेशर.
Okay, air vent cock is used to avoid the implosion inside the boiler, and it's also used to release the air inside the boiler while filling the water inside the filling inside the boiler. And the fusible plug is fitted at the crown plate of the furnace. Its main objective is to put off the fire inside the boiler when the level of water falls below the normal level. And the scum down blow down valve is used to remove the lighter oil and deposit it on the boiler. These all are the functions of the safety valve.
ब्लो डाउन वॉल्व जो बोला ना, वो सैंड्स एंड सेडिमेंट्स कहाँ से वो निकलता है? ऑयली तुम बॉयलर करके बोला, मतलब वाटर ड्रम या स्टीम ड्रम? वाटर ड्रम वो मेंशन करना चाहिए ना. वाटर ड्रम में जो भी मतलब अनवांटेड सेडिमेंट्स है वो निकलता है. और
and blow off cock, and the blow off cock is used to empty the boiler like the muds and sediments from the boiler. And is there anything remaining?
स्कम वाल्व और ब्लो ऑफ कॉक सेम है क्या? ब्लो ऑफ
हाँ, ब्लो स्कम डाउन वॉल तो हो गया, ब्लो डाउन वॉल और स्कम डाउन वॉल सेम रहता है। और ब्लो ऑफ कॉक तो मड और सेडिमेंट्स को निकालने के काम आता है।
ब्लो डाउन वॉल्व मतलब वाटर ड्रम में होता है, स्कम वॉल्व ऊपर होता है ना, मतलब स्टीम ड्रम में होता है ना।
हाँ,
मतलब सेम कैसे हो गया?
नहीं, ब्लो ऑफ कॉक तो है ना, मतलब जो है ना, ये जो मतलब अपने जो चलाते हैं ना फ्लू, मतलब लकड़ियां वगैरह जो उसको मतलब गर्म करने के लिए,
हाँ हाँ,
उसको साफ करने के लिए काम आता है ब्लो ऑफ
वो
कॉक।
ब्लो ऑफ कॉक, हाँ हाँ, वो अलग है फिर। ब्लो डाउन वॉल्व अलग है, ब्लो ऑफ कॉक अलग है, स्कम वॉल्व अलग है।
कॉक अलग है, या
हाँ ठीक है। स्टीम स्टॉप वॉल्व बोला?
हाँ, स्टीम स्टॉप वॉल्व बोल दिया। एंड सेफ्टी वॉल्स आर यूज्ड टू प्रोटेक्ट, सेफ्टी वॉल्स आर यूज्ड टू प्रोटेक्ट पीपल एंड आल्सो दे हेल्प्स टू रिलीज द प्रेशर इनसाइड द बॉयलर।
हाँ, स्टीम स्टॉप वॉल्व बोलो, क्या करता है?
स्टीम स्टॉप वॉल्व, इट्स मेन फंक्शन इज टू स्टॉप द स्टीम, स्टॉप द वेट यार। Okay, steam stop valve is its main function is to stop the steam inside the boiler when the pressure of the steam is reaches to the higher level.
मेन फंक्शन तो स्टीम हैमरिंग है।
या ओके,
मेन फंक्शन है स्टीम हैमरिंग है। मतलब वो जब तुम टैप खोलोगे ना, ज्यादा जोर से खोलोगे तो अंदर से जो वाटर रहता है ना उसको हिट करके वो मतलब ज्यादा एक्सप्लोजन होने का चांसेस रहता है, इसलिए हम स्लोली ओपन करते हैं। स्टीम हैमरिंग को अवॉइड करने के लिए ही हम स्टीम स्टॉप वॉल्व यूज करते हैं एक्चुअल में।
ओके,
मेन फंक्शन स्टीम हैमरिंग है। स्टीम स्टॉप वॉल्व बोले तो इट इज यूज्ड टू अवॉइड द स्टीम हैमरिंग, इतना बोले तो भी चलेगा वैसे।
ओके,
ठीक है। गेज ग्लास बोला ना, गेज ग्लास?
या गेज ग्लास और वाटर लेवल इंडिकेटर सेम है।
फिर सारा हो गया। वेंट कॉक भी इम्प्लोशन अवॉइड करके बोला। हाँ ठीक है। मैनुअल, कैन यू टेल?
Okay, boiler has many mountings on it to ensure to ensure safety. First, and it consists of a safety valve, a gauge glass, a pressure gauge, a pre-check valve, then blow down valve, steam stop valve, some blow down valve, water low level indicator, then fusible plug, then vent cock.
Okay, explain everything.
Okay, first I start with safety valve. It is used to it is a valve that will lift when the pressure will become above the desired safety pressure.
1 second. Till then, Shubham, you draw. 1 second. Till then, Shubham, you draw the centrifugal pump again. Practice that. Means you can you can see and you can draw. You are lagging in that only, right? So tomorrow only it is their exam. Yeah, tell me, Manuel.
Okay, and the second I will talk about the gauge class.
1 second. You Google करके ही मतलब draw कर लेना, मतलब वो कैसे है ना, अच्छे से draw करो शुभम। Okay. Yeah, tell me, Manuel.
Gauge class is used to find the level of the water, and it uses a pressure difference to find the level of the water. And after that we have a pressure gauge. We use a border type pressure gauge here. In order, we should use a high quality pressure gauge, and in every 5 years we should change this pressure gauge. And after that I will talk about the steam stop valve. The steam stop valve ensures it allows the steam from the boiler to the pipe, and it also we should also ensure while opening the steam stop valve, because to ensure hammering is not taking place. When we open it fully, steam hammering is not taking place. We should open it slowly in order to ensure hammering is not taking place. And then next one I would like to talk about is the water low level indicator. If the level of the water it is used to indicate the level of the water. If the water level is less, it's shut. And the other one is the fusible plug, in which the temperature go beyond the desired temperature. The metal inside the fusible plug, to say tin, it melts, and the water from the water side comes and cuts off the combustion. And the other thing is the air vent. It is used to relieve the air while the entering and discharge of the steam. It is used to prevent the carbonic acid from forming and to say hammering, and while shutting it down, is used to prevent the implosion. So these are all the functions.
Okay. Boiler blow down valve, you explained it, right? Boiler blow down valve.
Actually, I didn't explain. I told that boiler blow down valve is used
Explain.
to. Okay, is okay. Boiler blow down valve is used to get the mud and impurities out from the from the water drum. Like if there is any impurities or any mud present inside it, we will open it and we will ensure that it is clean. And scum blow down valve, in the scum blow down valve there will be debris, floating debris, and in order to clean this debris, we use scum blow down valve. Okay. These are all the mountings.
And feed check valve. Feed check valve.
Feed check valve. And feed check valve, this is a two-way valve. One is it has two valves. One is one does not allow the go back of the fluid or steam into the suction side, and this and other one is the screw valve, which can be screwed in or down if you want to release or enter the fluid.
Yes, proper. And next question, what he will ask? And Faraday's law he will ask. You tell. Manuel.
Okay, according to the Faraday's law, when a conductor is kept in a varying magnetic field, it produces an EMF. And if the circuit is completed, and in a conductor, it will produce an induced current. And second law states that the induced current is directly proportional to the rate of change of magnetic flux.
Yeah. Okay. Lenz law. Can you explain?
Lenz law, the direction of the induced current, or that is the magnetic flux created by the induced current, always opposes the initial magnetic flux. This is known as the Lenz.
Yeah. Shubham. Okay. Faraday's law you explain.
Okay, the Faraday's has a two law. Faraday's first law of electromechanism states that the voltage induced in the conductor by changing magnetic field is equal to the rate at which the flux linking to the circuit is changing. And Faraday's second law of electromagnetism states that rate of induced EMF is directly proportional to the rate of changing magnetic field.
And Lenz law?
And Lenz law states that it states that the direction of electric current induced in a conductor by changing magnetic field is such that the magnetic field created by induced current is opposites initially changing magnetic field, is known as the Lenz law.
Okay. And can you explain the safety devices of the refrigerator?
Yeah, some of the safety devices. Okay.
Shubham, first you explain. Next I will ask.
Okay. Safety devices of a refrigerator are low pressure cutout switch, high pressure cutout switch, lube oil, low pressure cutout switch, liquid shock valve on condenser, and bursting disc, relief valve, master solenoid valve, oil heater. These all are the devices.
Okay, explain all.
Okay, low pressure cutout switch. Low pressure when the pressure inside the refrigerator at the suction side is lower than the desired pressure. Then the low pressure cutout switch activates and trips. Then high pressure cutout switch, when the pressure at the discharge side in the refrigerator is higher than the desired pressure, then the high pressure cutout switch will activate and trips and lube low pressure cutout switch. Okay, then when the level of lube oil is below the normal level, then the lube oil low pressure cutout switch will activate. Okay, the bursting disc is used to release the pressure inside the refrigerator. It gets permanently damaged, and the relief valves are used to avoid the system failure and release the over pressurized conditions. And the master solenoid valve master solenoid valve is used to prevent the refrigerant to enter inside the compressor. And the oil heater it is provided at the compressor crankcase oil and prevent the compressor from getting excessively cold. These of the refrigerator. Refrigerator safeties.
Yes. Manuel, can you explain?
Okay, first I'll talk about the low pressure cutout, and then cutout and cutting, and then high pressure cutout, then low oil pressure cutout, then relief valve, then oil heater, then I'll take both in this then main solenoid valve. These are all the safeties to explain with low pressure and low temperature. When the temperature of the atmosphere has reached the desired temperature, the low pressure trips stops the compressor.
Not the temperature, pressure.
It stops the compressor. It stops the compressor, low pressure trip, and telling about the high pressure trip. Even the when air entered or due to something, where the air entered or water entered in the compressor, the compressor produce high pressure, and due to this high pressure created for the safety of the compressor, the high pressure trips the compressor, and the whole system goes off, shut down. And talking about the low loop oil pressure cutout, when the loop oil pressure is not accurate, or it may damage the compressor. In order to propagate and safeguard the compressor, loop oil pressure cutout works and trips. And to talk about the oil heater, when the oil is extremely cold due to the compression, due to the compressor, in order to heat this, the oil heater is used. And to talk about the solenoid valve, if the compressor is not working, the flow of refrigerant is not needed. So the flow of refrigerant is shut by this solenoid valve. This one are the safeties.
Okay. In oil heater, you told that due to the compressor. Don't mention due to the compressor. Means.
Okay. I think I meant that. Okay.
Yeah. Means. Tell aram se, means like you can tell slowly but tell properly. Means Briganza will try to find the minor mistake and he will make it like a mountain. It might be look like stone for us, but he will make it like mountain. It is a big mistake karke like that. So okay, aram se you tell, and you tell properly. If you tell due to the compressor, now how due to the compressor, tell me karke, he will start asking like that.
Okay. So I will tell like if the oil temperature is less.
If the oil temperature is less than the less than the crank in the crankcase, no? If the crankcase oil is provided compressor in crankcase oil and prevents the compressor from getting excessively cold. Like that. Okay. Okay. Then Shubham, can you explain auxiliary engine safety device?
Okay, the auxiliary engine safety devices are overspeed trip, jacket water, high temperature trip, and the crankcase relief valve, lube oil low pressure cutout switch, and high exhaust gas temperature.
Yes.
These all are the auxiliary safety devices.
Yeah, tell me, explain.
Okay, the high exhaust gas temperature, when the temperature of the exhaust gases is higher than the normal level, then the higher exhaust gas temperature trip is activated, and the lube oil low pressure cutout switch, when the level of lube oil falls below the normal level, then the lube oil low pressure cutout switch will trip, and then crankcase relief valve. The crankcase relief valve is used to release the excess pressure from the auxiliary engine, and the jacket and the overspeed, when engine is running at the higher speed than the overspeed trip will be trip, and one is remaining, I think.
Yeah, high exhaust gas temperature.
Jacket water high temperature.
Yeah.
Jacket water high temperature. When the temperature of the water inside the auxiliary engine is higher than the normal level, then the jacket water high temperature trip will be activated.
Yeah. Manuel, can you tell?
Yes, sir. Actually, first I'll talk about the overspeed trip, then main engine, then water jacket high temperature alarm trip, no lube oil pressure trip, then high temperature gas. And first I'll tell about the overspeed trip. The overspeed.
You missed the crankcase relief valve.
The engine is running in overspeed. Okay, crankcase relief valve.
Yeah, tell me overspeed.
Crankcase relief valve, and of the overspeed trip. To talk about the overspeed trip, if the speed of the engine reached above the desired speed, the fuel will be cut off, and this cut off, and the engine stops. This is the overspeed trip. And to talk about the water jacket high temperature trip, if the temperature created by the generator is more, and in order to regulate the temperature, this is used. And if the talk about the low lumen pressure cutout.
Yeah, tell me.
Here, if the low boil pressure is very less, if the boil pressure is very less, in order to safeguard the fuel, low boil pressure cutout is used. Low boil pressure cutout. And crankcase relief valve. If the pressure inside the crankcase increased to eradicate pressure, this crankcase pressure relief valve is used. And the main engine exhaust on high temperature. The temperature falls if the temperature of the exhaust falls above the desired temperature, the engine strips. This is known as efficiency.
Okay, Shubham, can you explain the compressor safety device?
Okay, the compressor safety device. First of all, I am just giving all the compressor safety devices. Okay, wait. The compressor safety devices are the low pressure cutout switch, bursting disc, relief valve, water no flow trip, motor overloaded trip, water high temperature trip. So low pressure cutout switch, when the
relief valve will be there.
Sorry, I have already told.
No,
low pressure cutout switch.
relief valve compressor safety device में bursting disc
नहीं fusible plug, sorry fusible plug,
वही तो सोच रहा हूँ मैं.
हाँ, low pressure cutout switch, bursting disc, fusible plug, and water no flow tip, motor overloaded tip, water high temperature tip. Okay, lube low pressure alarm tip. When the level of lube is falls below the normal level, then the lube alarm trip will sounded an alarm. The bursting disc is present at the casing of the intercooler and aftercooler. It gets permanently damaged and releases the pressure. A fusible plug, when the temperature of air is above the normal level, then the fusible plug will get melt and release the pressure inside the compressor. And motor overloaded it. If the current taken by the motor during starting or running is higher than the normal level, then the motor overloaded trip will be activated and switch off the compressors. Water no flow trip. If the intercooler is choked and compressor is not getting cold by the intercooler, and the parts of the compressor is getting sized, so the water no flow trip constantly detects the flow of the water and activates the trip. And the water high temperature, if the temperature of the compressor is higher than the normal level, then the water high temperature, if the temperature of water in the compressor is higher than the normal, then the water high temperature trip will activate. These are all the functions of the compressor safety devices.
Water no flow trip में मतलब in this it is given
intercooler चॉक्ड हो जाता है उसके अंदर.
Not working on the flow of the water inside intercooler is not enough to cool the compressor, then the moving part is inside the compressor will get seized. मतलब water inside the intercooler में अगर water inside the intercooler is not enough to cool the compressor, मतलब water if we don't have enough water inside the intercooler, then water no flow trip will be activated. Like that it is given. It is not given like intercooler will get seized like that something.
No, I am not saying that intercooler is seized. And that's parts of the compressor is.
मतलब you told the intercooler is a choked, right? Choked something you told word.
Yeah, I have told her.
Choke नहीं होता है अगर water in the intercooler is not enough to cool the compressor to cool the compressor, then this water no flow trip will happen. It is not because of choking of the intercooler. Choking and not enough water, there is a huge difference. It is not the same. Okay. And Briganza is intelligent enough. He will पकड़ लेगा अगर ये कुछ गलत बोलेगा तो. And Manuel, can you explain?
First start with, I will talk about the bursting disc, then the fusible plug, then the motor overspeed trip, and the water no flow trip, and the water high temperature trip. I will talk about the bursting disc. Whenever the pressure becomes more, and the desired pressure in the intercooler bursting disc is present. If the pressure increase, it will leak into the air, leak inside into the water, into the water side of the intercooler, and it bursts. This is to safeguard the compressor. And second one is the fusible plug. The temperature of the exhaust, if the temperature of the exhaust increases above the desired temperature, the metal inside the fusible plug melts, and water will be flown inside. And the other is the motor high speed trip.
Water कहाँ से आ गया? Water will flow inside करके बोल रहे.
Actually in fusible plug, I think
boiler वाला fusible plug बोल रहे हो तुम. Means you are telling the fusible plug of the boiler. This is compressor. Compressor we cannot compress the water. Okay. You cannot mix it.
So to fusible plug, how will we explain the fusible plug?
Means you can tell that when the air temperature from the compressor is high, pressure is released by melting the fusible plug, by melting the metal. इतना ही बोल दो बस. हाँ. तुम boiler वाला fusible plug बोल रहे हो. You should not tell that. Don't mix up.
And and the motor overspeed trip. If the compressor is if the motor is in overspeed, it may damage the compressor. In order to safeguard the compressor, motor overspeed trip is used. And to talk about the water no flow trip, in the intercooler, the water is provided to cool the air. And if there is no water present, the cooling of the air will not be done. So in order to safeguard the compressor, water no flow trip is used. And water high temperature trip. And if the temperature of the temperature in the cooler and after cooler increases, it cannot be able to exchange the heat. It cannot access the heat exchanger, so it is the compressor will trip. It is known as water high temperature trip. It's all about the safeties.
तुम वाटर हाई टेम्परेचर का ट्रिप जो है ना शुभम, that you are telling in the water no flow trip. You have got confused with both. Okay. Water high temperature trip में है, if the intercoolers are choked or the flow of the water is less, then the air compressor will get overheat, and to avoid this situation, high water temperature trip is activated. So water high temperature trip का तुम water no flow trip में बोल रहे हो, मतलब don't get confused.
Okay.
हाँ. Then
मैं से बोल रहा था इसका thermostatic expansion valve का सिर्फ isenthalpic expansion बोलूँ ना अगर वो पूछ.
हाँ, isenthalpic expansion ही बोल दो. मतलब मैं डिस्कशन जब कर रहे थे ना, तब किसी ने adiabatic लॉ करके बोल दिया था, पर मैं जहाँ कहीं भी पढ़ा हूँ ना, सब में isenthalpic expansion ही मेंशन है. Everywhere it is isenthalpic expansion. So don't take risk. एंड लॉ बोले तो आइडियल गैस लॉ में वो चैट जीपीटी में देखा था, मतलब लॉ जो फॉलो करते हो आइडियल गैस लॉ करके है, मतलब आइडियल गैस में एडियाबैटिक लॉ ही है, पर तुम रिस्क मत लो.
बट आई थिंक द लॉ विल बी बेस्ड ऑन द जूल-थॉमसन एक्सपेरिमेंट, राइट?
सी आइसेंथाल्पिक एक्सपेंशन एंड जूल-थॉमसन लॉ, जूल-थॉमसन इफेक्ट बोथ आर सेम. Okay, either you can say the Joule-Thomson effect. It is a Joule-Thomson. It is not a law. It is an effect, and
but in the video,
that effect is called as isenthalpic expansion.
Yeah.
As
the professor, but in the video he told that it's a risk of telling this. So don't take risk by telling this.
Which one?
In VCRS video, no. Again's video. He is telling that we don't need to explain this. If only he asked, only explain. don't take risk, unnecessary risk by telling this.
Yeah, when you know why to take, this is an isenthalpic expansion only taking place, and it is that isenthalpic expansion was stated by the Joule. It is also called as Joule-Thomson effect. Okay, so but law which is getting followed, no, it is ideal gas law. Okay, so means ideal gas also what it is actually, see, saturated liquid refrigerant is entering into the thermostatic expansion valve, right? So it is a liquid. Ideal gas law is applicable for the gases. So what the scientists have did that means we can assume they have assumed the ideal condition to apply the ideal gas law. Means like they have made the assumption that it is following the ideal gas law. So that assumption is little risky to tell in the interview, because interviewer what he has in mind you have to tell that, no. But isenthalpic expansion you can state it, because isenthalpic expansion only taking place in every textbook. It is like that only. So forget about the ideal gas law, just tell that it is taking place, isenthalpic expansion is going to take place.
So that we can explain the graph also, like it is going straight.
No, if we ask you tell the graph. If you don't ask, just move on, right? Your aim is just to clear the interview, not to explain everything. You are not teaching there, you are just presenting your knowledge, that's it. How much interview is short, that much is better for you to get like that.
Okay.
Today he asked one special question, that what are the precaution you will taking in an compressor, starting of the air compressor. Okay. Shubham, you start first.
The some of the precautions of air compressor before starting of the air compressor are that check the lube oil level, and discharge valve should not be discharge valve should not be.
1 second, did I ask you, Manuel, did I ask no compressor safety devices also? I asked you, no?
Yeah, compressor.
Yeah, for both devices. I asked 3 also. Auxiliary engine, compressor, and refrigerator. No?
Yeah.
Okay. Then.
Okay. The precautions for the air compressor before starting the air compressors are that check lube oil level, discharge valve should not be closed, and the setting the pressure regulator, monitor the pressure build up, and check the environment, read the manuals, inspect the compressor, and drain water from the tanks, and regular maintenance, and turn off the pneumatic tools, and wear appropriate safety gears.
Yeah, this much only, right?
Yeah.
Okay. Can you explain, Manuel?
Actually, I don't know the answer of this question actually, and but I think we should ensure the lube oil pressure, lube oil level, and the suction side of the earth must be open. You should also also check the pressure gauge is working or not. You should also read the manuals, and we should also check the intercooler and aftercooler is working.
That much only. Okay, that tell me.
Yeah, that's only I know.
Okay, once you read it, means I also didn't read. He asked today only.
Okay.
Shubham, next question is what are the compressor accessories?
Okay, the compressor accessories are air hoses, air tanks, air filter, air dryer, and air blowgun, air compressor oil, wheel kit, and quick connect couplers, and extension cords and power cables. These all are the accessories.
Yeah. Manuel, you read?
I don't know about this.
Okay, read it. Okay, afterwards, means tomorrow is only there. No, he asked today this question for some guy and he rejected it. So.
Okay. So where can I get the PPT?
No, I sent in the group. This both the answer also I sent in the group. I will send you personally also. I think I have sent you also. I guess I don't know whether I sent you or not.
Okay, I will study.
Yeah. I have sent you, see, now. I didn't send you personally, but I sent in the group. Okay. Then, Archimedes principle.
Okay, the Archimedes principle states that when a body is immersed in a fluid, completely or partially submerged, the upward force exerted by the fluid on the body is equal to the weight of the fluid displaced by the body is known as the Archimedes principle. Examples are designing ships and submarines.
Yeah, then Pascal's law.
Pascal's law. When a fluid is incompressible and intensity of a pressure in a static fluid will be equal in all the direction is known as the Pascal's law. Examples are metrogate, hydraulic lift, and hydraulic ram, hydraulic press.
Okay, Bernoulli's principle.
Bernoulli principle. When Bernoulli principle states that when an idle and when an idle and incompressible fluid flows in a continuous system, the total energy of the particle remains same when a particle moves from one point to another point is known as the Bernoulli principle.
Yeah. Manuel, can you tell first Archimedes principle?
Okay, when a body is fully or halfly submerged in a body, an upward thrust is experienced by the body. This upward thrust is known as buoyant force. If the buoyant force is greater than the mass of the body will float, and if the mass is greater than the buoyant force, the body will sink. To take the example, ship floats due to this reason.
Which number?
What's
last what you said, ship floats on this
low. That's our complete.
Yeah, okay.
He is just saying, okay.
Yeah, I got it. And then Archimedes principle, no? Pascal's law?
Pascal's law, if the pressure is being applied on a fluid which is enclosed, the magnitude of the force will be equal to every part of the fluid. This is known as a Pascal's law. To cite an example, hydraulic lift and hydraulic lift and hydraulic pressure is also an example for it.
And then Bernoulli's principle?
The total energy possessed by a fluid is the sum of the kinetic energy, kinetic energy, pressure, and the gravitational potential energy is equal to constant. This is Bernoulli's theorem. To cite an example, venturimeter, and the flying of aircraft is also an example for Bernoulli's theorem.
Yeah, and आज भी मतलब NDT चालू का शुभम.
Okay, they are different methods of and they are non-destructive methods.
First
they are different methods.
Yeah.
Okay, the different types of NDT methods are like that: visual inspection, magnetic crack detector, ultrasonic testing, and red dye penetration test, and radiographic testing. These all are the NDT methods.
Yeah, explain on.
Okay, visual inspection. In the visual inspection, we are using the magnify glass to detect the cracks and porosity inside the material, and the magnetic crack detector. In the magnetic crack detector, we are using we are creating a magnetic field to detect the cracks and porosity inside the material by the help of permanent magnet or simple electronic magnet. The magnetic field shows the discontinuities by the leakage of the magnetic flux inside the material, and it can be detected by the help of magnetic particles on the body of the surface of the material. And the ultrasonic testing is also a type of non-destructive testing method in which we are using the high frequency mechanical energy and high frequency sound waves. It consists of parts like the pulse receiver, transducer, and display unit. The pulse impulsor is an electronic device pulse impulsor is an electronic device which produce high electrical voltage and transfer to the transducer. Transducer convert the high electrical voltage signals into the high frequency sound wave. Then this high frequency sound wave enters into the metal. When these sound waves reflected back to the transducer, then it is transferred to the transducer. Then transducer convert the sound waves into the electric signal, and then the fluctuating electrical signals will show on the display unit that there is a cracks or porosities are present inside the material. And the red dye penetration test. First of all, we clean the material. Then apply the penetrant to the material. Wait.
Yeah. Apply the dye penetrate in the area to be tested.
Apply the penetrant to the area we are testing to the material, and then wipe out the excess material from the material. Then after that we are sprinkling the developer on developer on the material. Then the developer then after wait for the 5 to 30 minutes, and then we see the cracks and porosities as a red line on the surface of the material. And the radiographic testing, in this we are using the alpha rays and gamma rays to detect the cracks and porosity inside the material. And then these rays are transferred to the material inside. And then when there is a cracks and porosities are present, then the deflections are shown on the computer screen. These all are the NDT methods.
Radiation show the discontinuities of the material in the and due to the strength of the radiation. डिस्प्ले स्क्रीन रहेगा कि नहीं मालूम नहीं, तुम बोल सकते हो वैसे.
रहता है.
Okay. Manuel, can you tell?
Actually, NDT, the process NDT is not a non-destructive test. It is a test which undergoes by not destructing or giving impact to the specimen. Firstly, we have visual inspection. Secondly, we have red dye pendant test and magnetic particle test, ultrasonic test, and radiographic test. First, starting with the visual inspection, it is just by looking through the microscope and through the lens by is there any problem or cracks inside the specimen, and this is how it is done. And talking about the red dye penetrant test, at first we clean the surface of the specimen and we apply the penetrant, and after applying the penetrant, the dwell time is allowed to dwell, and after that
your sound is hello Manuel.
Hello. Your voice is not coming properly.
Yeah, your voice is not proper. Means signal problem is there, kya?
Actually, I have only 4% on my phone. I think that's the problem. But XPR in big. No.
Yeah, means lot of disturbance is there. Can you at least connect the charger and tell the answer? It's fine. Even if the video is not coming also, it's fine. Just put on the charger and tell the answer. I am hearing. Next question, what can you ask? Wait. Shubham, तुम्हारा हुआ ना? Manuel, difference between the centrifugal pump and reciprocating pump.
Okay, centrifugal works on the principle of rotodynamic pump, and the reciprocating pump works on the piston and the reverse piston action. And in the centrifugal pump, centrifugal pump uses the impeller blades. In here, the reciprocating pump uses the piston pumps. Reciprocating pumps are not it cannot be easily maintained, but centrifugal pump can be easily maintained. For the installation charge is very less for the centrifugal pump than when considered the reciprocating pump. In reciprocating pump, it is used to create less discharge and more head, but in centrifugal pump, it is used to create more discharge and less head.
Yeah.
Okay, and in the centrifugal pump, there is we need to do priming. In the reciprocating pump, we don't need priming to be done. And we have a relief valve in reciprocating pump. We don't have a relief valve in centrifugal pump.
Okay. प्रेशर रेल क्या शुभम?
रोटरी पंप्स में होता है.
In the positive displacement pump there will be a pressure relief valve. In this centrifugal pump there is no pressure relief valve. We will use the air blower. Okay. Air blower whenever to maintain the constant flow rate, as the fluctuating flow rate will be there, no, in a reciprocating pump. To make it constant, we will use the air blower. There will be no this one pressure relief valve.
Okay. And the flow rate will be more constant in the centrifugal pump. The flow rate will be fluctuating in the reciprocating pump.
Flow rate will be fluctuating in the reciprocating pump. Yeah. Okay. Then Shubham, can you tell the difference between the reciprocating pump and gear pump?
Okay, the reciprocating pump works on the principle of reverse piston movement principle, and the gear pump works on the principle of positive displacement principle. In the reciprocating pump, we are using the piston movement, and the gear pumps we are using the gears or gears. And the
gears to transfer the fluid. Complete the curl.
Gears to transfer the fluid.
And piston is used to transfer the fluid like that.
Okay. And wait a minute. And in the gear pumps, they are relief valve is present. In the reciprocating pump, no relief valve is present, and both of the pumps do not require priming, and that's all.
ये तो common हो गया.
Okay, and दोनों है ना नॉन विस्कस फ्लूइड को फ्लू करते हैं और okay, the flow is fluctuating and pulsating in the reciprocating pump, and flow is continuous in the gear pump.
और
and that's only I see.
Maintenance is required more in a reciprocating pump and less in the gear pump. Last time में example दिया था ना, वो friction होता है piston. Piston में friction होता है, इसलिए ज़्यादा maintenance चाहिए. Centrifugal pump में भी तुम ये difference बोल सकते हो वैसे. और क्या है, और एयर ब्लोवर यूज़ करते हैं. एयर ब्लोवर हाँ वो बोलेगा तो भी चलेगा, नहीं बोलेगा तो भी चलेगा, इतना काफ़ी है. And Manuel, can you tell the difference between the reciprocating pump and gear pump?
Reciprocating pump works in the principle of reverse piston by movement, and the gear pumps work in the principle of positive displacement to transfer the fluid. And to talk about the piston is used to create the movement of liquid, and in the gear pump we use gear to create the movement of the liquid. According the maintenance and the post maintenance and post is more for the gear pump, more for the reciprocating pump than the gear pump. In the gear pump, both the pumps do not need priming. Then air blower is present inside the reciprocating pump. Air blower is present in the gear pump. In the gear pump is used to produce more head than the reciprocating pump.
क्या more head क्या? वाह, क्या more head?
More is more pressure. In gear pump we can deliver more pressure than like in the reciprocating pump.
In a reciprocating pump ज़्यादा pressure create करता है ना? शुभम?
I thought about.
I don't know about that actually. So that's why I'm not.
I thought also I will neglect that point.
Yeah.
The flow is very
priming point also. It is similarity. It is not a difference. How can you tell the priming is don't require in both?
Okay. So the flow rate is fluctuating inside the flow rate is fluctuating in the reciprocating pump. The flow rate is more consistent in the gear pump. And the cost of the cost I have already mentioned. Then in the gear pump in the gear pump we need more we do not need more area, but in the reciprocating pump we need more area.
Okay.
This all.
Yeah. Tell me what is the difference between reflection? What difference? Reflection and refraction.
The reflection is the bouncing back of the light from the solid surface. It has two laws. The angle of incidence is equal to the angle of incident ray is equal to the angle of reflected ray. And the second law is that the incident ray, reflected ray, and the normal lie on same plane. And the reflection is that when the light enters from the rare to denser medium, they bend. It follows the Snell's law. Snell's law is that the sin I upon sin r is equals to constant. Sin I is known as the incident ray, and the sin r is known as the reflected ray. And constant is equals to mu r upon mu I, reflective index of the reflected ray, mu r, and the mu I is the reflective index of the incident ray.
Okay, Manuel, can you tell once?
Reflection is the bouncing back of the light reflecting back of the light on the same plane. And to start about talk about the refraction. Refraction is the shift of the light when it passes through one medium to another medium. That's only I know about refraction and reflection.
Yeah, and in this reflected ray, and there is this much only is there actually. And sin this one you can tell, no, sin of angle of incidence divided by sin of angle of refraction is equal to constant, and constant is a refractive the index, that is the refractive index of the reflected ray and a refractive index of the incident ray. So
but the problem is that I don't know much about the reflection, but if anything he asked about the equation and all, I don't know anything.
No, he doesn't ask anything actually.
Okay.
This question was asked to only one person. I don't know. He has tortured him. He asked all the questions whichever I asked. No. He asked every question, and then that person has got stuck in the reflection and refraction. This part. Okay, then he rejected him. Means only one person he asked in the total history of his interview. So tomorrow also he will not ask. So only this whatever you told, no, this much is also fine.
Okay.
But you study about that today, whatever he asked, no, precaution for the compressor, and and another thing whatever he asked, accessories, compressor accessories. So that too you just study.
Okay.
Then other than that और क्या क्वेश्चन बाकी है? सब हो गया ना? ब्रिगांजा का तो हाँ, टेम्परेचर ऑफ द इवेपोरेटर इन अ डोमेस्टिक रेफ्रिजरेटर.
Okay. The temperature of the evaporator in the domestic refrigerator is depends on the types of refrigerant we are using, because it varies according to the refrigerant we are using into the refrigerator.
Okay, Manuel.
We cannot according to the refrigerant type only we can assume the temperature and the pressure of the refrigerant in the evaporator coil. So I think in order to know that, we should know the type of refrigerant used.
ठीक है. और एक हाँ, strength and weakness, Shubham.
Okay. So one of my biggest strength is that I consider myself as a good leader, because when I am the engineering, I am the coordinator for all the engineering department to organize the fest and the programs in my college. And while in between the fest, my college exams are also going on, so that's why I knew how to manage the situations easily and how to communicate with the people. And I have never given chance to my organizers and professors to blame me for my work. And I think this kind of character will help me on the onboard shape to make the justice for my seniors and super seniors for their expectations. And I am also awarded as a best leader award by the Jaipur Super Bikers to continuously organizing a riding programs in Jaipur. And this is my one of the biggest strength, I think.
And weakness?
And sir, one of my weaknesses is that I am little bit weak in English speaking, so that's why I am just working on it, and I am just taking English speaking classes.
तो ये मैं भी यही बोला था, सेम टू सेम. और Manuel, tell me strength and weakness.
To start upon my strength, patience which I gained in my technical knowledge in my company is the best strength which I have, and I also believe that the correct time thing on the correct time is the best thing, and sincere work should need. And another strength was that I was the leader of the Faradays group in my company, which is the Faradays. I also served as a prize for getting for completing a project. That was sustainable managing. And to talk about my weakness, I'm not that good at writing.
Manuel, I think whenever you tell about the strength, no, you also tell that how can you apply that strength in this field and make him, means you while telling strength, no, you have to make me feel that because of this strength I want to select you. Like that, you have to make me feel like that. And, when you tell about patience and everything, you tell that this character will helpful in the onboard ship also. So to continue my work or something like that. Okay,
I think this strength which I talked about will be very beneficial on ship. And punctuality is very big thing in the ship. So I think these are my strengths. And to talk about my weakness, I'm not that good at writing, but I'm trying to write many things so that I could develop my skills.
Writing?
Yes. I saw in Pranit's video that he told that his weakness is.
ठीक है. और क्या छूट गया? अभी फीडबैक ही देंगे. मतलब फीडबैक तुम्हारा मतलब शुभम, तुम्हारा ड्राइंग है ना, ड्राइंग प्रैक्टिस कर लो. सारा ठीक है, मतलब सिर्फ ड्राइंग ही प्रैक्टिस करो चलेगा. सेंट्रीफ्यूगल पंप का इंटरनेट में जो रहता है ना, वही ड्राइंग प्रैक्टिस करो. और गियर पंप का भी मतलब तुम मेशिंग नहीं किया था, वो मेशिंग करना बहुत जरूरी है, वो मेशिंग के वजह से ही वो सक्शन और डिस्चार्ज के बीच में डिफरेंस पैदा करेगा। सो एंड एरो मार्क सब देख लियो, मतलब सेंट्रीफ्यूगल पंप में इम्पेलर से बाहर आते हुए एक एरो मार्क चाहिए, वहां से मतलब डिस्चार्ज साइड से तक तुम ध्यान रखो, मतलब तुम किए थे ये ध्यान रखो। एंड आई ऑफ एन इम्पेलर में तुम मतलब कैसे रोटेट हो रहे वो बनाए थे ना, मतलब एरो मार्क।
अच्छा, मुझे बोल रहे हो क्या आप?
हाँ, तुम्हें बोल रहे हो, एरो मार्क बनाया था ना, किस डायरेक्शन में रोटेट हो रहा है। हाँ, उतना ही है। और गियर पंप में भी मतलब एरो मार्क इम्पोर्टेंट है, प्रेशर रिलीफ वाल, हाँ वो सब तुम बनाए थे। हाँ ठीक है, इतना ही है, मतलब तुम्हारा ड्राइंग ही थोड़ा प्रैक्टिस करो, बाकी सब तो ठीक है, मतलब कहीं भी गलत नहीं है वैसे। हाँ, और एक तुम बीच में एक गलती किए थे ना, मतलब वाटर हीटर में और अदला बदली किए थे, इंटरकूलर में के अंदर चोकिंग होता है करके किसी को बोले थे ना। हाँ, वहाँ एक गलती था तुम्हारा। हेलो हेलो, आवाज आ रहा है?
हाँ आ रहा है।
हाँ, और एक गलती तुमने वहाँ किया था, मतलब कंप्रेसर सेफ्टी डिवाइसेस में हाँ वही, मतलब वहाँ पे ध्यान रखो। और एक गलती तुम स्कम वाल्व जो है ना वो मतलब स्टीम ड्रम में होता है, और बॉयलर ब्लो डाउन वाल्व वाटर ड्रम में होता है, मतलब वो भी मतलब देख लो मतलब। और बाकी सब ठीक है, तुम्हारा कुछ प्रॉब्लम नहीं है वैसे। और तुम्हें कुछ बोलना है मैनुअल, व्हाट यू थिंक अबाउट हिज?
I think except the speed, like if he reduce the speed, the interviewer will think that he has not mucked up anything. He is thinking by himself. If he reduce the speed, some that's only I think, but the rest all he is perfect.
मतलब वो बोल रहे हैं, मतलब तुम जब स्पीडली बोलोगे ना, वो इंटरव्यूअर एक बार मतलब वो मिस कर देता है तुम जो बोल रहे हो, इस उसके वजह से थोड़ा स्पीड कम करो करके बोल रहे हो। ओके मैनुअल, तुम्हारा मुझे लगता है सारा में ठीक है, बट प्रिकॉशन ऑफ द कंप्रेसर और एक दो क्वेश्चन छूट गए थे ना। ओके, 2 क्वेश्चन विच एवर यू लेफ्ट नो, हाँ दैट क्वेश्चन यू स्टडी, and other than that you have told everything properly. In the centrifugal pump you have missed, no, means like from an water enters into the eye of the impeller and it will comes out through the guide vane. This question he will ask tomorrow, no, so you know that he is asking, then you make it perfect. Tomorrow he is going to ask definitely.
Yes.
So you should not make any mistake. Okay. This is a very much important. If you, in basic things only here you go wrong, no, further question he will not ask only, he will reject you after asking one question only, like that. So don't make mistake, and you can see in PDF I have wrote everything properly, by heart it today, and after that in gear pump you told everything properly, there is no mistake. 2 stroke, 4 stroke, everything you told properly, only Shubham, you in a reciprocating pump you told no pressure relief valve, don't mention that. There you went wrong. Okay. And in the ultrasonic this one ultrasonic testing transducer you have missed. Okay. Then other than that you told everything properly, there is no mistake. And 2 stroke and 4 stroke difference you told that fuel is used high quality in 4 stroke, there you made mistake, don't make that.
Then, I will not tell that about the quality of the. Okay.
If you are not sure, no, better you don't tell, it's fine. If you tell wrong,
but in my PDF it was there, like in my old PDF it was written that quality of the fuel.
This, so don't mention it. And then other than that you want to tell anything, Shubham, to Manuel? No. Where he wants to improve? Hello. Shubham, you want to give any feedback to Manuel, means where he wants to improve or something? What you
just improve on the centrifugal pump, that you are just lagging some points about that.
Okay.
Hello. Yeah. And and all the thing, I think all the things are clear.
Okay. Manuel, if you can't reduce some speed now while talking, then it will be fine. You also means like
okay.
Means like while telling, you tell so fastly. Means like you will give the pause, but not in between the words when you are talking. No, means like you will tell like flow rate is constant, and then you will give the pause. Means like while telling the flow rate is constant, you will tell very speed. That is the problem.
Okay.
Means aram se you can tell. There is no
and
don't make a hurry bari. Means like aram se you tell. One interview it is. So okay then. All the best, both of you.
Thank you.
Okay.
All the best, Shubham.
Thank you. All the best, Manuel.
Yeah. Okay, thank you.
Tomorrow you should how much best you can do, you do today and practice today. This is the only day. Tomorrow is the final
day.
Yeah, you practice your best. Okay.
Yeah.
Okay. If anything is there, you can call me anytime. You can ask me. You can text me. You can. Okay. Bye.
For your time.